All right, today we're diving into something really cool in the world of network security. It's an AI called Kitsune, and it's designed to be a clever little fox that guards your network, learning and adapting in ways that are just incredibly smart. So, let's see how this digital fox actually works its magic.
So here's our game plan. First, we'll look at why the old way of doing things, our current network watchdogs, are kind of falling behind. Then, we'll meet Kitsune itself. We'll get into the weeds of how it spots things that don't belong, why having a team of AIs is the secret sauce, and finally, we'll see the results when they put this thing to the test.
Okay, so let's set the stage. What's the actual problem we're trying to solve here? Well, the systems we rely on to spot intruders on our networks, Network Intrusion Detection Systems or NIDS, they're really struggling to keep up with today's threats.
I mean, just think about it. Attacks are getting way more sophisticated, there are more of them than ever, and they change constantly. The old-school methods we've been using to fight them, they're just not built for this new reality. They feel, well, outdated.
And just look at the traditional process. It's such a slog. First, you need a human expert to sit down and manually label just mountains and mountains of data. Then you need a beast of a server to train the AI model, which takes forever and has to be done offline. And after all that, you end up with a static, unchanging model that you just load onto the device, hoping it knows what to look for.
So when you break it down, these traditional systems are just so high maintenance. They constantly need expensive humans to hold their hand. They can't learn on the job from live network traffic, especially not on your everyday router. They're too beefy for cheap hardware. And the worst part? They have this closed world view. If a brand new attack comes along, they are completely blind to it. It's like they've never seen it before, so it might as well be invisible.
But what if we could flip the script entirely? This is where Kitsune comes into the picture. And it's not just a small upgrade, it's a totally different approach to network security.
And the name is just perfect. In Japanese folklore, a kitsune is a fox spirit that grows more tails and gets more powerful the wiser it becomes. That's exactly what this system does. It's a security tool that uses a whole team of AIs that learn and adapt on their own, getting smarter and stronger just by watching your network's traffic.
And check this out. It directly solves all those problems we just talked about. It's unsupervised, which means no more human babysitters labeling data. It figures out what's normal all by itself. It processes everything online, learning from live traffic as it happens. And it's designed with low complexity, so it's lightweight enough to run on cheap, simple devices.
Okay, so that all sounds great, but how does it actually work? How does it spot something that just doesn't belong? Well, the magic is in a clever type of AI called an autoencoder.
An autoencoder is a really cool kind of neural network. The best way to think about it is like a super specialized digital artist. You train this artist by showing it thousands and thousands of examples of only normal, boring, everyday network traffic. It gets incredibly good at sketching that one thing perfectly. So the whole process is actually pretty simple. First, the artist learns what normal looks like. Then you show it a new piece of live traffic and say, hey, sketch this. If the traffic is normal, the sketch is perfect. But if it's an attack, something the artist has never seen before, the sketch comes out all wrong, a total mess. That messiness is measured as a high reconstruction error. And a high error score, that's our red flag. That's the alert that something is wrong. Now, this is where Kitsune's real genius comes in. This is its secret sauce. Instead of using one giant, overworked AI artist, it uses a whole team of them, just like the mythical fox with its many tails. See, one huge AI trying to learn everything at once is just slow and complicated. It gets bogged down really fast as the network gets bigger. But Kitsune's approach is way smarter. It uses a team of smaller, specialized AIs. Each one is just responsible for watching a small piece of the network. It's so much faster, way more efficient, and it makes it easier to spot real threats hiding in all the noise.
And to top it all off, there's one last AI that acts as the team captain. Now, this output layer doesn't watch the network traffic. It watches the team. And here's the genius part. It learns the normal pattern of their errors. It gets to know what a normal mistake looks like for the team, so it can make a final, super accurate judgment call on whether a threat is the real deal.
So the theory is beautiful, right? It all sounds amazing on paper. But the big question is always, does it actually work in the real world? Well, the researchers put Kitsune through its paces to find out.
First up, speed. By using that team of specialists instead of one giant AI, Kitsune was able to process network data up to 5 times faster. I mean, that's not a small improvement. That is a massive leap in efficiency.
Okay, so it's fast, but is it accurate? This chart shows its detection performance, where a score of 1.0 is absolute perfection. And just look at Kitsune's results. It scored a 0.999. That is basically perfect. It actually performed better than some of the slower, more resource-hungry offline methods. It proves you don't have to trade accuracy for speed.
And here it is. This is the kicker, the real punchline to this whole story. All of this incredible performance, the speed, the near-perfect accuracy, the self-learning, it was all running on a device the size of a credit card. Yeah, a simple Raspberry Pi.
And that's why the researchers themselves said it best. This makes Kitsune a truly practical and economical solution. You could put this kind of smart, adaptive security into every single cheap router and device on a network. Imagine that.
And so that leaves us with this really fascinating thought. We're looking at a system that can learn to defend a network all by itself on incredibly simple hardware. If our security is becoming truly intelligent and autonomous, what does that mean for the next generation of cyber threats and for the defenses we're going to have to build to stop them?